Can I ask one more question?
Sure.
Um, so in the question number 3, to calculate CPKM. So for that, we can use the CPK value from part C, right?
Yes.
Okay, thanks.
Okay. So had one question before I started recording, and someone argued that this could be read, that P could be shifted by 20%, but what I intended for this is the P has shifted to 20%. So the new P value in the shifted state is 0.20. Okay, so that's what I meant. So there was a question on what I meant there, and that was a question before I started recording the class. I guess being I answered the question as part of the class discussion, it wasn't recorded. I decided to go back and rephrase that. So a little unusual start to the class. And yeah, there we are. Just the 5 of us for now. I'm guessing maybe Ace might log in a few minutes, as he commonly does. As we had last week in my other class, I had a default password. Zoom's defaults have changed, and one of the things was it would require it would generate a password and require it for to view recordings. I somehow I thought that those titles were protected enough for me. And the website definition with all those random characters in it. Well, some of them might not be random, but be just a little hard to guess. But I don't know. Somebody my class for the fall, someone's managed to figure out how to create recordings in it, but no one's I think actually using it for that. I suppose it is possible that somebody is using that meeting account for to get a longer than the free usage rules for Zoom. I don't know. Anyway, probably should go to the slides. So here we are. It's April 22nd. Fairly late in the semester. It's warm now. as we've seen in the news again, uh, the COVID 19 has caused a difficulty in rescheduling. Uh, Pretty much all the on-campus events at the School of Mines are shut down till um, beginning of July, and um, things are quite a bit different. Uh, we have been seeing some controversy this week about opening things back up. Uh, we'll we'll see how some of that plays out. Um, one of the chapters I did have prepared already was chapter 16, the other sampling techniques. So we can look over that, other acceptance sampling techniques, and we can look that over. This procedures, I uh, with the variables techniques and acceptance sampling, I haven't really worked anywhere where this was regularly applied. Whereas with the attribute stuff, I did, let's see, work for about 2 years at Emerson Electric in quality when this was being used. And the attribute stuff that we talked about 2 weeks ago. But but the variable stuff we didn't use regularly. Um, and where I worked for 2 years, and then I did 5 academic quarters and a few odd months on sides of those quarters with General Electric. So almost a year and a half in a quality department. Um, and we broadly use the attributes sampling systems, but didn't go through and work with the variables techniques that are here. Although um, they're they'd been well established at that time, as we can see. Uh, let's see assignments. There have been some changes with Zoom as far as Zoom bomb and yeah, and five early in March, right after we came back, there were some concerns if we should even have live login or just go to purely recorded classes. And the resolution was uh, it's probably better to do what we've been doing in the class all along, which was to offer the live login, however, not to require it. Uh, and some of you do like to actually ask the questions live, and that's a facility that we can provide for you. Talk about suggested problems placed on D2L. I don't have any problems set up for chapter 16 on D2L. So on your last exam or last assignment, uh, I don't see me asking any questions on that. So I hope I don't hear a bunch of uh, ringing of logouts just at that. So this is useful, but um, useful information, but um, not necessarily something that you'll see on further graded portion of the class. And yeah, there are sort of 3 editions of the book that I've worked on. I've had slides from the 6th edition, and they don't. I have at times sat down and with various editions of textbooks, and just flip pages, and they were amazing in the consistency which the pages were even laid out. So accordingly, uh, I haven't always felt real motivated to build new slides from edition to edition. I guess the fourth last meeting was on 3/3, and as I said before, we didn't think there was any COVID-19 in South Dakota at that time, although we're learning now that COVID-19 may have come earlier than we thought to the United States. And we had we had extended spring break, and just on 3/24 we decided we were going to go online for the entire semester, and the proctored exams didn't work very well, except it turns out that we at least I don't think so. Dr. Kirk just wanted to broaden the definitions of proctor, and was hoping that would be that way. I would prefer not to do that. I could see some people in relatively hectic homes trying to put together, being honest and saying they're dedicated to something for 3 hours or something. It might be difficult. Yeah, we're supposed to go business as usual until like 11:20 a.m. on March 24th. Second exam. Second exam is due on April 25th. Most of you who are here were there, so there was some discussion even about ending the live login, but we're still with that. Zoom Zoom changes things as things go forward. In some ways, to better meet the needs of the client group. There were some things that having some difficulties with. Although there were a few instances at the School of Mines of some Zoom bombing, you don't always have the same same problems as Zoom did in like a high school situation, or younger students even. You expect a little more security from what's said, and tolerance there, and of what actually is put forward. So old comment on my phone, it's still there. We're still keeping the numbers. I haven't been in the office a long time. I've got my cell phone nearby. I'm not so sure how much it's charged at the moment. But I'll try to keep that the home phone. My wife also answers or ignores it sometimes, so that isn't always reliable. Although some of you have called me at home, and hopefully that's worked out to your satisfaction. We're using D2L. You did get email people have successfully logged into the classes, and we've had that site for the whole semester. I might have to change it if you can't have some problems with it. I guess we only have maybe one scheduled session left. Check an email to see if I've changed it. We do have the streaming video by Zoom. However, it's a little less convenient than it had been because the passwords are there by default. There are other ways to send videos, and we could probably still work those out if we had to. At one time, for a number of years, we mailed DVDs and mailed DVDs to everybody. And before that, we mailed VHS VHS tapes, and that got a little clunky. So uh, where are we? We're here. Don't really have a plan for next week. We do have finals week, a final exam session on the 6th scheduled. We when I put up that last assignment, I'll give a due date. I'm thinking now it might be better just to have all kinds of things due on May 8th, the last day of finals week, and let me work through that and try to get some stuff out before the end of this week in both my classes. So other acceptance sampling techniques. So I guess a few years ago I had this statement, this is really a discipline in itself. I can't really say that because there just aren't that many people who work in this compared to other areas of statistics. But just say that there have been big thick books on this. Chapman and Hall. So what's in the chapter? Acceptance sampling by variables. These are these continuous measurement stuff, and we can do things like that. We can look at acceptance sampling with them. We want to design a variable sampling plan with a specified OC curve. So there are questions and procedures like that. There is military standard on how that works. So welcome, Ace. Let's see. All right. So Ace is here too. Let's okay. See, there were a couple of questions on the exam. On the take-home exam for this class that I discussed at the beginning of the class. So Ace, you might want to try to look those over. And I guess I probably should tonight work pretty hard on getting that email out to everyone, maybe a little early. So something comparable to the mill standard 105E, uh, something similarly in philosophy for variables, and then some other procedures about variable sampling. And just some curious things. We can do sequential sampling by variables too, which may make more sense. We can do something called chain sampling and continuous sampling also. And we'll explore those differences. And a big idea is skip lot sampling plans, something that we're more likely to think about. Can we, if things are going well, can we skip a lot in sampling? Makes some sense. And you can work out some reasoning for that. So what are the objectives? Understand the difference between attributes and variable sampling plans. Probably did that 2 weeks ago. Know what advantages there. Two major types of sampling plans, how to design a variable sampling plan with a specified OC, understand the structure and use of mill standard 144 and civilian countercard plans. Chain sampling, continuous sampling, and skip lots too. So, and kind of an ugly slide. So, accepted sampling by variables. Big advantage, you can have the same operating characteristic curve with smaller sample size than would be required by an attribute sampling plan. So if your sampling gets to be somewhat time consuming or expensive or equipment intense, switch, especially if you can get a variable, that might be a big advantage. Second advantage, those continuous measurements usually provide more information than the attributes data. You can plot a histogram of your measurements, for example, if the sample size is large enough to merit that, or at least a CDF plot or a box plot, and that can give you some idea of the shape of the distribution and maybe what some of the difficulties are meeting specifications. A final point is when the acceptable quality levels are very small, sample sizes required by attribute sampling plans are very large. So we now have that problem there with the when we try to get very tight, that the attribute sampling gets really large, and then pragmatically you end up doing 100% inspect on this stuff. The variables plan will let you get away from that. Disadvantages, the distribution of the OC curve must be known. So we have to know the distribution. And the standard plans assume the distribution of the quality characteristic is normal. That in practice isn't always true, especially if you can get some very weird distributions. You might, for example, in certain components, have different grade levels. Some might hold your grade A might have a certain characteristic within plus or minus 2%, grade B plus or minus 5%, and grade C plus or minus 10%. When you get those, you try to make as many as you can with to grade A. And if you happen to make too many grade A's, you can still sell them as grade B's because they meet the spec, and still sell them as grade C's if they meet the spec. However, if you have a very hard time meeting the specifications at each level, and you're maybe even making too many grade C's that you want, you will not sell the you will not sell the anything that would qualify as a grade A in the grade C bunch. So you end up getting a distribution with a big hole in the center, which is somewhat disheartening if you're assuming a normal distribution and you get just a big hole in the center with two bounds on the other side. Yeah. And this is a massive one. A separate sampling plan must be employed for each quality characteristic that is being inspected. So you might have you might inspect the physical dimensions, 2, 3, 4, 5 physical dimensions on a part, and then you would have to go through and do calculations for each of those, and that of course could be quite difficult. Then this bizarre fact here: if your distribution assumptions aren't right, which we argue they could be, quite possibly, and for example, you use a standard system and you assume normality, and your measured characteristic isn't normal, you could actually your inspection, you could end up rejecting a sample of parts when it doesn't contain any defective items, which is a very very difficult thing to explain. Entirely possible. So, two general types of variable sampling plans: plans that control the lot or percent defective, and plans that control the lot or process parameter. Okay, so two ways of looking at that. we want to control either a process parameter or usually a mean. And different sections of the book cover those. So consider a variable sampling plan that controlled a lot or process fraction nonconforming. Very often, yeah, to get this, we need a lower specification or an upper specification or both, and then define the acceptable values of this parameter, illustrate the situation. Let's say X is normal, so we'll look at that picture in the next slide, and a symbol P represents the fraction defective in the lot. Note that the fraction is a function of the lot and mean, and we have a process standard deviation. We suppose we know the process standard deviation. We can organize the calculations of sampling plans in a couple of different ways. So here's the idea. We have this process. It has a lower spec limit, and if the process has this distribution with this mean and this standard deviation, and then we have a spec limit. If we know this and this, we then can calculate the, if we know the distribution type and all the parameters of this distribution, we can then calculate the proportion out of spec. Most often, we'll talk in this book about normal distributions. However, other types are a concern also. So here's a procedure. We can calculate a z-value, much like we've done in other places. X bar, the statistic, minus the spec limit, and divide by sigma. Yeah, this is the way you would use this. This calculation ends up being not necessarily the way you would do this if you were defining it. When you have the X bar here, usually your calculation for a Z has it divided by the square root of n. Remember having this discussion with a student earlier in the semester. However, when we're actually doing calculations in like a shop level, simplifying the formula and just having it tabled for a different sample size is useful. So the larger the value of Z sub LSL, the further it is from the spec limit. So we're good if, and we'll have a smaller percent effective. So the larger the Z sub L would only be changed. Notice the X bar is the only statistic we're calculating here. This is given and this is assumed known at this point. So we can just set this up so that if our z sub LSL is greater than a specific value for a fixed sample size n, we'll accept a lot. Because as you look at this, if our X bar is larger, it would indicate that this um, this distribution is shifted to the right, thus causing a smaller LSL, a smaller value of P beyond the outside of the LSL limit or blue area. So if the LSL is too small, we will just reject a lot. So that's a procedure for one-sided. It's we can go through equivalent rules for, flip things around a little and use a USL value instead of a LSL and have sort of a mirror argument for it. Now, there could be a two-sided test, and one way to do that is another procedure is to estimate p hat, the proportion defective, and if it's too large, go and do that. So that you could do with a normal table in this sense. So that's an alternative procedure, just either calculating the z or estimating the p hat proportion defective. If you have two-sided, then that could work well. Now sigma is unknown. You could then use an S value and do similar stuff. Then you'll need to make use of a t distribution to estimate your p hat. That gets a little sloppy when you're working with tables, but if you have Excel or Google Sheets or R or many other statistical packages, that isn't too difficult. At one time, the plans based on R were in wide use because it's simply easier to compute by hand. The much of the quality controls things, as we look at some of the standardized plans, we start seeing some dates in the 50s, and many of you don't really have a sense of like the history of computing devices common to people and so forth. because you're young, relative to that history. Uh, so your personal handheld calculators weren't really generally available till like the mid 70s, and that's something that's useful to know. And those with standard deviation features that were commonly built in were actually kind of expensive in the mid 70s. As as time went on, though, of course, they got more modestly priced. Um, uh, so just a point of historic perspective there. Um, usual the usual assumption is the parameter of interest follows the normal distribution. So all these things. So if you get a distribution that doesn't look very normal, uh, uh, eh, to attempt to use variable sampling, you're going to have to go through it on your own. Um, uh, so this could get very shaky because trying to actually the distribution of what actually gets sent in uh, in in a lot can change over time. Uh, for for various reasons. Uh, so yeah, it's kind of obvious if the point two, if the normal theory doesn't work, it just this this whole game is done. And that isn't the produced fraction. We may be talking about, let's say, an incoming inspection situation into a plant, and you may be getting a sorted product. So what might have been a normal distribution has been truncated quite a bit. Um, by the time it gets to you, have been changed. So yeah, a lot of stuff can go wrong with that assumption. Um, so nice idea. Trying to you can't have a right have a vendor tell you the distribution of the contract the distribution of the parts that are coming in. At least I haven't heard of that. Uh, um, so the K method, procedure one, we specify an OC curve. So probability P1, probability of acceptance of 1 minus alpha, and P2, uh, probability of acceptance P2 of beta are 2 points on an OC curve. Uh, so acceptable and rejectable levels of quality um, respectively. So we can do that. Um, there have been nomograms developed which you set a critical value of K and find a sample size. If you have P1, P2, and beta, and with sigma known and sigma unknown characteristics. So with either a Z or T kind of table. So you have different scales. Wow. So so yeah, if the sigma is unknown case, you have a greater sample size. However, the same value of k is the way this nomogram is designed. So here's nomogram. Probability of acceptance on one side, and probability and fraction defective on the other. And sample size for known n and unknown. And then what do we have on the edges? And these are the k values. Okay. So what's the game here? We want to accept at 90% likelihood things, probability at let's say 95% likelihood of a 0.01% defective. So we could just draw that one line. Well, so we have P1 of 0.1. This example, I guess, just read it through. A soft drink bottler buys non-returnable bottles from a supplier. The bottler has established a lower specification on the bursting strength of the bottles of 225 pounds per square inch. If 1% or less of the bottles burst below this limit, the bottler wished to accept the probability. So 0.95, 1 minus alpha is 0.95, and P1 is 0.01. Whereas if 6% or more of the bottles burst below this limit, we would like to reject with a probability of 90%. So beta is equal to 0.10 and P2 is equal to 0.6. So we can, do we have those answers drawn? Well, let's see if I can get this right. 2 points. P1 0.01 and alpha 0.95, and that gives us one line. So go back and let me write these. Let me write these down so I can do this all in one setting. So P1 0.01 and 1 minus alpha is equal to 0.95, and P2 is equal to 0.06, and beta is equal to 0.10, and so forth. We then could use this those 2 points to determine our K value and our N value for our calculation. So I've got those written down here, and I'd like to be able to draw with a line tool, and PowerPoint doesn't give me a line tool. However, Zoom does. So we can go about and we can draw our line with Zoom, and let's just take a look at what color we have. Oh, okay. We've got that. I can erase that. That's black. That should be contrasting enough. And maybe I could just draw freehand off to the side what we're looking for. So P1 is equal to 0.01, and then 1 minus alpha is equal to 0.095, and then P2 is equal to 0.06, and then beta is equal to 0.10. So for some reasons we like those, and what is that? That's a green. It should be contrasting enough. Go back and draw a line and see what we have. To the left, we have our P1 value of 0.01. So we find that here. And then we take it across the way to the 0.95. So we start here, and we draw down to 0.95. Draw the one line, and then P06. We have to somewhat guess where that one is. Assume it's roughly linear, so here maybe about a fifth of the way, and beta is equal to 0.10. And then what do we get? Can draw. What do we observe? If sigma known, K equals and then N equals, and we need to just find those. And I'm old enough where they actually taught me to write with these. So N for the sigma known plan, we trace down Do I have a pointer? Or I have a mouse? Oh, highlight that so we can trace this back, this sigma known line. And if I'm tracing it back correctly, we're getting about 40. So our n size will be n will be about 40 for the sigma known case. And then our k value, we would have to read across those lines. And then our k value works out to, looks like about 1.9. K equals 1.9. This is what I get. And if sigma is unknown, um, and sigma unknown, so we can follow this back up, and it still looks like it's about 40. So at least the way I or trace those back, or does this trace back down differently? Maybe I made a mistake in tracing it down. Yeah. Seems to work out 40, but so let's see if that's the answer. Now, because I used line tools from Zoom, these drawings will carry on to the next screen, if I understand correctly. All right, so those were our numbers that we got, and we can scale down. Solution 40. So curve line 1.9, 40, sigma unknown, and also reading these down works out, works nicely. Huh. I must have misread that chart a little. Um, this is for the other charts for the M method are shown here, and have the eraser clean those up. So also some nomograms have been developed for the oh my gosh. Uh, um, so there are also some comments about using some um, other books, other methods, and Duncan's book is actually a competitor to um, the book we use. So the M methods calculation for plans and some other nomograms, and those are actually the nomograms shown at the bottom, given as slides on their own. So those end up being useful if you actually want to make the drawings, and if you have the PowerPoint and you want to make use of these, you can um, pull the image, um, pull the images off, and and make use of them more directly. So um, you don't have to scan a textbook or snip an electronic textbook. Um, or do is uh, before snipping tool was around, there is a print screen command in um, as one of the function numbers uh, in Windows, which essentially allows you either to save a window or an entire screen, and then you could then put that in appropriate drawing tool and edit it instead of doing just a snip directly. Um, uh, Example 2, consider the situation, design a sampling plan using procedure 2 is, so same problem, go about um, more complicated uh, values that we can come up with um, values for um, and this just illustrates the use of those other charts. We can then talk a little bit about how these things are done. We talked about Mill Standard 105 E 2 weeks ago. We then can go about there's an analog for that in the um, set up in the variables sampling for lot by lot acceptance sampling by variables, the Mill Standard 414. And there are ANSI and ASQ standards for that also, and they're available in various places. Um, I looked, and Wikipedia doesn't really have as big a discussion on um, Mill Standard 414 as it did Mill Standard 105E. We looked earlier, and that wasn't worth breaking out and showing. Although there are many websites where that is included. So similarly to the Mill Standard 105E, things focus on the AOQL, or roughly the producer's risk, within ranges of 0.04% to 15% AOQLs. And then there are 5 general inspection levels, and sample sizes are a function of the lot size and the inspection level. So there's provision for normal, tightened, and reduced inspection level, and everything's assumed to be normal of this quality characteristic that we're looking at. Um, um, so we have how things are organized there. So variability unknown, we have ranges, and we have variability known. So there's 3 inputs there, and then we have single-sided specs and double-sided specs. And then we have a K method and an M method. Uh, each of those could be used. Um, So typically we have tables that look like this. We have the 5 different inspection levels, and then we have uh, and let's see where the A's and B's come from. So we have our inspection levels, and it tells us our criterion that we're set at, the B's, and we go through, and similar, we have lot sizes of 100,000. Variable sampling plan uses procedure 1. Assume the lot standard deviation is unknown. If we use inspection level 4, the sample size code is O, and we find the sample size code is O, N equals 100, acceptable for an acceptable quality level of 1% on normal inspection. K is 2. If tightened, 2.14. AOQ values for normal inspection are listed at the top, and the AOQL values and the AQL or AQL values tightened at the bottom of the table. So it talks about provisions of when to go from shifted to reduced. And calculations for that. And the full details of the switching procedures are described in the standard and in a technical memorandum published by the Department of the Navy. Now, the recommendation here is to, these, of course, we make our judgments based on the mean. However, we have to verify that sigma or S is known. So it's also a good idea to run a S or an R chart, depending on what you have, to see if those characteristics are running consistently too. Um, Now, it's not possible to move directly from an attribute sampling plan to in the current mill standard to a corresponding if the assurance of continued protection is desired at certain levels. So the civilian counterpart restores the match of attributes compatible with the mill standard 105E. So there are switching. The systems do run similarly in the civilian counterparts. Well, so much for that. Now, in practice, of course, this is a lot of difficulties. We have the normality assumption. We have the calculations required at each point, and uses like sampling to provide assurance regarding average quality. Manufacturer wood paneling supplies substrate blanks bought offshore supplier to determine the formaldehyde emission level. As long as the mean emission level is less than 0.3 ppm, the lot is satisfactory. So this is simply I think this is the same. Sigma is equal to that emission level. This looks like the same problem we had before. Okay, so this is actually just the same calculations you would usually do to calculate your common z values, this statistic, and then if we calculated our Z statistic, and we could then just use the values off the Z statistic for the 0.95 probability of acceptance. So in other words, this is just what you would do with a usual Z table of designing sampling by variables procedures of calculating a Z. And here's another thing we could do: sequential sampling, useful in attributes inspection. So we saw that 2 weeks ago. Usual assumptions is that the quality characteristic is normally distributed standard deviation. The process is known. Item by item sequential sampling by variables, the cumulative sum of the measurements of a quality characteristic. Line limits for the accepting the lot, rejecting continuous sampling are constructed much like attributes. So there's a discussion of the design by those. So we can do sequential sampling pretty much like we did with the attributes. However, we'll just essentially run a Q sum, and we'll either accept, reject, or continue to sample. Now, so So the chain sampling idea is that we can use history of previous lots in our planning. And again, this this is set up here in attributes discussion. So this is not a variable system. This is a attributes system for chained inspection using previous. So this section alternatives, we slip back into the attributes plan and have a special case of this. So you might want to put this section in the previous chapter, chapter 15. And some nomograms for that. Continuous sampling. Now, sometimes we actually don't get lots in the sense that there isn't a natural lot that's occurring. Parts just move through sequentially, one by one, at certain operations, manufacturing devices. But we could go and switch to and from sampling, running in a, so we start out with do something like this. Start with 100% inspected, and if I consecutive units are defect free, we'll continue. No, if they are, if a fraction F of the units are defect free, inspect a fraction of the units selected in a random manner, and then when we have no defects, we continue. When we go and get a defect, we flip back to 100% inspection. So we can play this game of continuous sampling. So if we have a long run of things in control with no defects, we can then go forward. Um, and then as soon as we get uh, a defect, we'll have to go back to 100%. And these are the chain sampling plans. They're AOQL set up for chain sampling, and this slide probably should have been moved up. Or this is continuous sampling plans. We have the F. And for various fractions inspected F, we can get an AOQL out of the system, assuming, perfect at various numbers that we would run for I. And I there is the number of consecutive units being defect free to let us flip in. So AOQL, if you remember from 2 weeks ago, is average outgoing quality. Is average outgoing quality level limit. In other words, when we run the system and we run and switch to continuous inspection, on average, this is the maximum percent non-conforming that we would assume if we run this plan at any value. So if you have a very low um, if you have a very low um, percent non-conforming, of course, you'll have you will just run at that low level. If you have a very high percent non-conforming, you'll run 100% inspection all the time. But there's some middle ground there where you will be bouncing back and forth between the 100% and that as you go forward and apply this, there's some maximum level of a defect that could get through at a certain percent effective. So the AOQL, that limit of if when we're flipping back and forth, how much could get through is that definition. So it's somewhat difficult calculation. So we want to know proportion of units under inspection and fraction defective before inspection. For various plans, for various I and F values. So the original CSP1 designed to meet those. So we have some very old plans. Dodge and Tory proposed plans to meet the objective that the occurrence of a single isolated defective unit sometimes would not warrant 100%. So there were variations on that. Lieberman and Solomon introduced multi-level continuous sampling plans to overcome the abrupt transition. And these other continuous sampling plans are in mill standard 1235. No, I see what escape, new share. Do I have Oh, okay. We can go look at this. Hide meeting controls. And maybe look up what mill standard. Uh, 1, 2, 3, 5. Uh, who has articles on this? Oh, escape. Looks like we lost somebody. Ross, Kevin.
What's that?
Looks like we lost somebody. Can't remember who that was. I heard a dropped line. I don't know if you guys hear that or not.
I only see 5 attendees though.
Okay. Yeah, I think we had 6 for a while. I can't remember who. So some discussion. So the Department of Defense no longer supports that. However, ASTM standard exists. So what does ASTM say? So there is an active standard by ASTM that was replaced this, and you can. Whoa. uh, kind of pricey there. 26-page document for $72 in a PDF. Anyway, so yeah, there's still active versions of that. Where's my Zoom? What do I have? I've lost my Zoom controls. I don't know what happened to the Zoom here. Is anybody still listening?
I'm here. Well, I
I'm
see it.
listening.
I don't see it.
You don't see it. Uh,
Do you have share your screen?
I've lost my controls somehow.
All right. It says here you've disabled your screen according to mine.
Okay. How is there a way for me to re-enable it, or?
On the bottom of your thing, you should see chat, and you should see your share screen and your record.
I don't see that right now. All I see is a Zoom control bar, and
Maybe if you see Alt tab, if you press Alt tab, maybe it will show all screens. So one of them should have.
Alt tab, you suggest?
Yeah.
Okay.
It will show you all the windows.
Alt Tab shows me all the windows. And
One of them should be Zoom.
can I go back and click the uh, PowerPoint maybe? Do you see the PowerPoint now, or
No.
no? I can hit the Alt Tab. I still Alt Tab, Alt Tab, Alt and Tab. Whoa. This is don't save. Okay. I don't know what Zoom is doing here. Maybe I'll go to my Zoom control panel, and it's already started. My start is blanked out on this. I don't know what's happening with this meeting now. My controls are disabled. And I show video.
It's still recording, so it's working, I think.
It's still recording, and oh, okay. It gave me I now see my usual set of controls. And I don't know what I did. uh, I I had yeah, I don't even know how I got back. So share PowerPoint, get back there. All right, from current slide. Right. Skip lot speaking. We have lot by lots. We can play a game where maybe if we have a certain number of lots running well, we can skip a lot. So much like this um, continuous sampling, we can skip lots and still work forward and maintain a quality level. So those things have been developed too, and there's some calculations for those and how to get OC curves on various skip lot rules. Some calculations for those. So much for that. I'm sorry. I really don't know what I did to. I guess I accidentally clicked on something and all my controls went away. That Alt Tab seemed to help. It gave me some things. I really didn't know what was going on. So we talked through some of this briefly: skip lots, continuous chain sampling plans, and then variable systems and some references on those. So not too much except to give sort of a breadth of sampling techniques here. I'm leaning towards, for most of you, just weighting the three, the two exams and the final assignment equally. And I do have the suggested problems and haven't really gone to any R for this class. Why is this one of the last slides? Well, thanks for listening. look for some email. The take-home exam is due on April 25th is a regular due date, and I think I can start grading a bunch of those. Then um, we'll look forward to that, and I'll look at coming up with a final assignment too. Um, let's see.
Dr. Frank, is there any time for submission or any time on 25th?
Any time for the submission?
I mean,
On the
is it like
25th.
until 5 p.m. or like it could be even midnight?
Um, I'll look at I'll look at new share, and I'll look at uh, share and hide floating meeting controls, and we can go and look at D2L. I'll see what I put. D2L. Statistical process control, and what I do, view as university student. So as university student, assessment, Dropbox, exam to what did I have set up there?
11:30.
Yeah, I guess it says 11:30. So and do I have accepting late there? Submit files, upload, add a file, submit, must click to submit. Yeah, that's the folder information, and the exam is there, uh, and for you to submit. So yeah, that's the 11:30. And if you have some problems with that, I believe I can I change my view as university student? Do I cancel and start seeing my own viewpoint? So assessments, Dropbox, the take home. What do I have with this? Mark is red. Okay, I do have some people who've submitted already. I guess I shouldn't be scrolling that down. Email, download, mark as read, delete. Show, oh, those are search options. Edit folder, email.
Thank you, dear.
Let's see what it shows me. Take home, save and close. Submission, individual type, group category, submission, files unlimited, submission, all submissions are capped, notification, email, exam category. I believe it, if you submit something late, it just simply see restrictions, has due date, okay, 11:30, has start date, has end date. No, I didn't put a end date on there. So if um, if you do submit it late, I'll still see it. So there isn't an end date for the assignment. I believe that's the way that works.
If, let's say, Professor, let's say things go bad for some reason and you can't upload for one reason or another, would you still take an email submission if we were to send you an email?
Uh,
I don't plan to. I didn't have any problems uploading. But let's say for some reason it's the 11th hour and things are, panicking over here.
uh, yeah, I would I would really prefer the uploads, but in a I have let people do that emergency sort of email thing. Uh, I'll I really would prefer not to, but I'll look
Right.
for emails. It's much I'm it's much harder for me generally to find emails than it is the than to find things in the D2L. So I really prefer it, but I'll I guess I can say here I'll accept that in a emergency late kind of thing. So, if it's 12:02 uh on the 26th, that you 12:02 just after midnight on the 26th, and you sent an email saying I was having a real difficulty with D2L uploading these files and they were attachments. I'd certainly take that. Now, yeah, if you're having problems, um, if you're having problems with D2L, I haven't actually had many students have problems submitting D2L. Uh, some people have sent things by email uh, because they had forgotten the instruction. But usually the people who've tried it have had a reasonable time with that.
Oh,
So
Professor,
yeah,
I fully agree that we should be using D2L. But if, let's say, there was some issue with D2L or something along those lines, there's nobody at the campus that's going to be able to get on the phone and say, can you unfreeze my account or this? Or, in other
yeah,
words,
yeah,
there's
yeah.
no
There's
backup.
yeah, there is no backup. The email systems are more reliable. That's for sure. Uh, so yeah, I'll take it if you have difficulties with D2L. And D2L is not a campus service; it's a contracted service. So it is entirely possible that D2L could go down um, i- for various reasons, but um, the email would still be working. That's that is possible, and there may be some files that D2L doesn't like that email would take. That's technically possible, but I can't really cite a situation where that would work. Um, okay, maybe a new share on my uh, uh, final slides here and take home do, and then look for uh, email on final assignment and uh, look for the email on the final assignment and uh, um, next week's class. It could be, maybe we'll just answer questions on that final assignment next week. So I'll have to think that through yet. So so thanks for everything. We're wrapping things up. I'm trying to sort things through with the COVID situation's been a little more difficult than I thought. So and it's starting to get dark outside, and the lighting's looking a little different in the room. So we will end the session a little early this week, and I'll get to all this computer files I'll have to mark up soon. So we'll look for an email on what we'll do. And one of the things I am considering is next week just answering questions regarding the final assignment that I'm going to give. So we'll I will just end the class here. So thanks for staying around, Ross, Kevin, Shalib, Ace. We'll we'll be working on setting things up for the end of the semester now. So I'll stop the recording now and then end the meeting.